So our discussion today will start from the mode. The mode as the third measure of central tendency, so that we can be able to know what is the mode and how is it calculated. One, mode, it is actually the element or the number that is most repeated. It is the number that is most repeated in a distribution. Allow me to connect. A number that is most repeated in a distribution is what we refer as the mode. Therefore, a distribution can actually have one mode if we have got only one number that is mostly distributed. So if we have got only one number that is mostly repeated, then we are going to have that data as a unimodal. So a unimodal kind of data, it is where we have got only one number. One number is mostly repeated. In some cases, we can have two numbers that are appearing the same number of times. When you count them, they are actually appearing the same number of times, but they are the most repeated. In that case, we are going to have a data we call a bimodal. Bimodal, whereby we have got two numbers that are mostly repeated. And then we have a data we can call multimodal, where we have got more than two numbers that are most repeated. So in a unimodal kind of a scenario, maybe you have got this data. It is 8, 9, 6, 4, 9, 5, 7, 10, 9, maybe 6, like that. You can be able to note that 8 is only appearing once here, 9 is appearing 3 times, 6 is appearing twice, 4 is once, 5 is once, 7 is once, and 10 is once. So in this case, we can simply come here and we say that the mode is 9. We can simply come here and we say the mode is 9, because it is only 9 that is mostly repeated here. Then that kind of a data is known as a unimodal. That is a unimodal because it is only one number that is mostly repeated here. In a bimodal kind of a scenario, you can have here, maybe we have 11 and then we also have 6. So 6 is repeated 3 times. 9 is also repeated 3 times. So in this case, mode is going to be 9 and 6. If we have such kind of a scenario whereby we have got two numbers that are appearing the same number of times and they are the most repeated, then that kind of a data or distribution is said to be bimodal. But when you say what is the mode, you say mode is 9 and 6. When we come to the multimodal, it is a scenario whereby we have got more than two numbers which are our mode. Maybe we have got 9, 6, and maybe 4. When there are more than two numbers that are mostly repeated, then that kind of a distribution is the multimodal. So first of all, note that mode, it is actually the number or the figure that is mostly repeated in a distribution. And in a distribution, we can have either unimodal if it's only one number that is appearing more number of times, bimodal if we have got two numbers which are appearing more number of times and they are actually having a tie, and then we have got a multimodal if there are 3, 4, 5. So long as it is more than two numbers that are appearing more number of times, then that kind of a distribution is said to be multimodal. I will remind you on what we said on Tuesday. We said that data is of two categories. We have got data we call ungrouped, and we have got the data we call grouped. This one we discussed on Tuesday. For ungrouped, it is the data that is normally written down and separated by commas. Like for example, if we can have 100, 101, 105, 98, 67, this kind of a data is said to be ungrouped. But when we have the data that is behaving like this, maybe 0 to 5, 5 to 10, 10 to 15, such kind of a data, then we have got the frequency here, maybe it is 8, 9, and 6. This kind of data is said to be grouped, whereby now we group them into classes. So when we go to mod, we are going to talk about mod from ungrouped data. And this is actually the simplest. If you are given a data like this, and then you are told to determine the mod, it is just a matter of counting each number of time, or each number, the number of times it is appearing. The one that is going to be appearing more number of times, then it is your mod, as we did here, as we did in this example here. You just count the number of times each figure is appearing. The one that is going to be appearing more number of times is actually your mod. So when it comes to ungrouped data, it is very simple. Just count how many times it is appearing, then the highest is your mod. But now when we go to the grouped data, for the grouped data, mod is calculated using a formula L plus FO minus F1 over twice FO minus F1 minus F2. And then this portion here, we multiply by I. We multiply by I. But the key thing here, it is to note what is L, what is FO, F1, and F2, and also I. Once you are able to know what they mean, then it is very, very easy. You note that L, it is the lower class limit of model class. Lower class limit of model class. Then FO, it is the highest frequency. Highest frequency. F1, it is the frequency above F naught. F1, F2, this is F1, this is F2, it is the frequency below F naught. And then I, it is the class interval. L is the class interval. So let us do a question here that we are going to apply this formula and see how easy it is. You can be given a data that is presented like this. You are given maybe the income of workers, and maybe the number of workers. Income of workers you are given as follows. Maybe this is how they are paid. Let's say it is in 1,000. This figure is in 1,000, so that maybe we have 100 to 150, maybe 150 to 200, 200 to 250, 250 to 300, and maybe 300 to 350. Then you are given the number of workers who are earning that kind of income in this bracket from 100 to 150,000. Maybe there are 3 workers. 150 to 200, there are maybe 7 workers. 200 to 250, maybe there are 13. And maybe in this bracket we have got only 4, and maybe here it is only 1. Now you are told determine the mod income. What you need to do, you come here and you quote the formula. Mod is calculated by L plus F naught minus F1 over twice F naught minus F1 minus F2. Then we multiply this part by I, like that. But now you need to note which is our F naught, which is F1, and all that. First of all, note that the model class is the class with the class with the highest frequency. The class with the highest frequency, it is your model class. Remember now, the number of workers here will be our frequency. So you just come here and you know which is the highest frequency. The highest frequency is 13. Therefore, this class where 13 belongs, this is your model class. This 200 to 250 is your model class. The moment you have identified the model class, the lower limit is the L. The lower limit of the model class is the L. So in this case, L will be equal to 200. F naught, it is the highest frequency, which is 13 in this case. F1, it is the frequency above F naught, which is 7. 7 is the one that is above it. And then F2, it is the frequency below F naught, which is 4. And then I, it is the class interval. You just minus 250 minus 200, you get the class interval is 50. Then you subject these figures, or you substitute these figures in this formula for you to be able to get the mode. Therefore, our mode will be given by R, which we have said is 200, plus F naught was 13 minus F1, which is 7, over twice F naught, which is twice 13, minus 7 minus 4, which is our F2. And then the whole of this we multiply by 50. That one will give us our mode. So it's going to be 200 plus 13 minus 7, which is 6, over, this is 2 times 13 is 26. 26 minus 7 is 19. 19 minus 4 is 15. Then we multiply by 50. Therefore, this one is going to be 200 plus, what is, can you do this for me? 6 divided by 15 times 50. 20. So the mode in this case is going to be 220. The mode is going to be 220. Actually, once you get the mode, you will find or realize that the mode is going to be somewhere between or somewhere within this class that we identified as our model class. The mode will be a figure that is between 200 and 250 because that is where your mode belongs or your model class. So that is how simple we calculate it. You will realize that when it is mode, we don't create additional columns. We don't create additional columns. The table that you are given in the exam is just enough for you to calculate the mode the way it is. It is not like the mean where we prepare the x and then we have the fx. It is not the same as the median where we normally have the cf so that we can do all that. For the mode, the table, the way it is just enough for you to calculate that particular mode. One thing I would like to emphasize at this point, when it is median or mode, some cases you can be given data that is not continuous. If you look at the data that we used here, it is continuous. Continuous in the sense that where this class is ending, this other class, the next class begins from there. It ends here. Where this one is ending, it is where the next class is beginning. Like that, like that. This is a continuous kind of distribution. In some cases, you can be presented with a question whose data is not continuous. Maybe you are given information like this. You are given information like these are the classes. Maybe you are given 0 to 5, 6 to 10, 11 to 15, 16 to 20. You are given like that. Then you are given now the frequency here. Maybe it is 8, 13, 14, and maybe 3. Then you are told find the mode or find the median. One thing you should be very keen is on the nature of these classes or this data. Is it continuous? In this case, this data is not continuous. So you need to make it continuous before you start calculating either the median or the mode. With the mean, there is no problem. You can just calculate it the way it is. But with the median, you must you must do actually rearrange this information to be continuous. Allow me to, let me share again. So what you will be required to do here is simple. Just add 0.5 to the upper limit and then subtract 0.5 from the lower limit. Add 0.5 to the upper limit and then subtract 0.5 from the lower limit. So excluding the first one. So if we add 0.5 here, you'll find that this one is going to be 0 to 5.5. Then if you subtract 0.5, in all this, excluding the first one, all this we subtract 0.5 because they are the lower limits. And all this we add 0.5 because they are the upper limits. So you'll find that this one is going to be up to 5.5. If we subtract 0.5 here, it's going to be 5.5 to, then we add here 0.5, it's going to be 10.5. This one is going to be minus 0.5, it is 10.5 to, this one we add 0.5, going to be 15.5, subtract 0.5, it is 15.5 to 20.5. And now your data is continuous. And now you can go ahead and calculate the mode or the median. Remember, now you have your frequency here, and then you can calculate. One thing you realize that what will change is only the air. Air will change. In this case, if it is mod, the model class was 11 to 15. But now you cannot use 11 as your L. You will use 10.5. You will use 10.5 as your L. You arrange it. The only difference will be the air. Instead of 11, use 10.5. The data must be continuous. That is the point I want to emphasize in this case. But the formula, it does not change. So having said that, we are through with the measures of a central tendency. We have seen how we calculate the mean, the median, and the mode. Having done that, now we can go to the measures of dispersion. The measures of dispersion. The measures of dispersion. With the measures of central tendency, we said that this is one figure, or it is one value that represents the entire data. If it is in an examination, we get maybe the marks of all the students, and then we calculate the mean, and then we say that the performance of that class is the same as the mean of that particular class. So that mean is becoming a representative of the entire class. Or we are looking for the mean wages. If we take maybe 20 employees and we ask them about their monthly income, and then we calculate the mean income from those 20 employees, then we take that mean to be the income those particular workers are earning. Like that. But now here, if it is one value that is representing the entire distribution, we can ask ourselves, how true is this one value representing the entire distribution, from where or from which it was corrected? If we had that students who sat for an exam, and then we go ahead and calculate the mean score for that particular subject or that particular exam, and we say the mean score is maybe 58%. Now we can ask ourselves, how true is this 58% representing the performance of that particular class? So that one can be done through calculating the measure of dispersion. So the measure of dispersion, we want to know how far is the mean. We normally use the mean instead of the other three measures of central tendency. How far is the mean going to represent, or actually represents the true values from where it was calculated from? Therefore, if we find a case which can be very funny or very rare to witness, if we had maybe 5 students, if we have 5 students who sat for an exam and all of them they scored 55, The 5 of them, each of them scored 55%, which is very rare. But if that is the case, you will realize that the mean will be 55. If we add all this and then we divide by 5, the mean is going to be 55. The mod is also going to be 55, and the median is going to be 55. Therefore, if we go ahead and we say that the mean is 55, it is going to be a very perfect scenario. Yes, the mean is 55, and it is very true that each and every person scored 55. In that case, we don't have a dispersion. Dispersion here, it is the same as the deviation. It is the same as the deviation or variation. We want to measure how the mean is deviating from the actual values. So because the mean and the actual values are actually the same, all of them, then there is no deviation, there is no dispersion, or actually the dispersion is 0, and we can simply say that that mean is correctly representing the entire data. But practically, this is very rare to happen. It is not actually going to be true that all the students who sat for an exam, all of them scored the same marks, unless maybe they were copying from the same source. It is not true that you can ask the employees and all of them are earning the same income. It is not actually going to be true if we measure the height of people and we find that all of them are having the same height. The same case to weight. If we measure the weight of individuals, it is not going to be actually true that all of them are going to exhibit the same weight. Now, we might now require to know the mean weight, the mean score for the class, the mean height. We want to know how true is it representing the actual values from where it was calculated. Now, the lesser the dispersion, the lesser the deviation, the more correct that mean is. Like, for example, if we come here and we calculate the mean or the score for these people is the first one scored 56, the other one scored 55, the other one scored maybe 57, this one scored 54, and maybe this one 53. This is the score for those 5 people. The way you can be able to see here, if we calculate this mean, and maybe, can you calculate for me? Can you add all this and then divide by 5? If you add this value,
55.
you get the,
55.
yes, the mean is 55. Yes, if you look at the mean, which is 55, and you go from to the data from where we calculated the mean, you can be able to see it is only one person who had 55. The others, they did not score 55. Now we want to know how far is this score from the mean. So you find that this one is having a deviation of +1. This one is having a deviation of +2, and this one is having a deviation of -1 because it is below the mean. This one is a -2, and this one, the deviation is actually 0 because the mean and the data, they are the same. So if you look at these deviations, the deviations are very small. The deviations are very small, and therefore we can say that the mean is almost correct. Is actually almost representing the data from where it was corrected. But if you find a case like this, you have the data, the scores were maybe, let us start with the 55. The other one is 75. There is another person with 35, and there is another one with say 95, and there is a person with 15, for example. Now you are told you find the mean. Can you get for me the mean? Remember, the mean is normally denoted by x bar. What will be the mean here? Can you add for me and then you divide?
55.
You find it is 55. Now, when you go to the actual figures from where we calculated the 55 from, you can be able to see there is a person with 15 here. This is actually negative 40. This is positive 40. This is 0. This is positive 20. This is negative 20. You will find that the deviation is very wide. The deviation, even if we are saying that the mean is 55, it is very wrong because actually there is somebody with 95. There is somebody with 15. So this mean it is far from true. It is very far from true. So the measures of dispersion will give us a clue on how far is this mean to the actual data from where it was corrected. The higher the deviation or the dispersion, the more incorrect that mean is. The lesser the dispersion, the more correct that particular mean is as far as the actual data is concerned. So the measures of dispersion, we have got different methods of calculating them. So if we can come here and we talk about the methods of calculating the dispersion, we have the first one, which is actually the range, which is the easiest to calculate, which is simply given by the highest value minus the lowest value. That is the range as one of the methods for calculating the measures of dispersion. Like in this case, if we can go to these examples that we had here, in this case, the range is actually 0 because the highest and the lowest value, they are actually the same. So if you minus 55 minus 55, the range is 0. And then we can be able to see that there is no dispersion there and that data is very correct. When we calculate the range here, the highest is 57, the lowest is 53. So 57 minus 3, it is actually a deviation or a range of 4. So the range is very small, so we can be able to say that this mean then it is going to be almost true. But when we calculate the range here, the highest is 95, the lowest is 15. If you get the difference between the two, you find that the range is 80. And therefore we can be able to see that the dispersion is very big, and therefore the mean that is going to come from that data where the range is very big, that mean is not going to be a correct representative for the entire data. So the range is very simple. Just get the highest data or the highest value, in this case maybe 95 minus 15, you get this one is going to give you 80, and that is your range. So it is as simple as that. But when it comes to, remember this data, all the data that we have talked about here, all this data is ungrouped because they are just separated by commas. But in case you are given the grouped data, in case you are given the grouped data, like maybe you are given 10 to 20, 20 to 40, 40 to 60, maybe 60 to 80, and then 80 to 100, like that. When you are told you calculate the range for this, you take the lower limit of the smallest class. The smallest class is this one, between 10 and 20. It is the smallest that we have. You take the lower limit and you take the upper limit of the highest class. So it is the upper limit of the highest class minus the lower limit of the lowest class. In this case, it's going to be 100 minus 10, and you can say that the range is actually 90. So that is how we normally do it. For the ungrouped data, pick the highest value, you minus the lowest value from that distribution. For the grouped data, it is the lower limit of the lowest class and the upper limit of the highest class. So it is the upper limit of the highest class minus the lower limit of the lowest class, then it gives you the range. So the range of these values, it ranges from 10 to 100. So the range is 90. The range is 90. So it is actually the simplest to calculate. Having said that, allow me to go to the second method of calculating the dispersion, which is known as the standard deviation. This is one of the method that is highly tested in your area, so it is worth understanding. So the standard deviation, still, we need to know how do we calculate the standard deviation from ungrouped data and from the other data which we call the grouped. Let me start with the ungrouped data. So if you are given the data like this, maybe it is the score of students in an exam. They scored maybe 48, 55, 60, 63, and maybe 42. That is the score of those students. Now you are asked, determine the standard deviation for this performance. For ungrouped data, the standard deviation, which is normally denoted by that sign, it is given by the square root of summation of x minus x bar squared over n. The summation of x minus x bar squared minus n. Remember, x bar, it is just the mean. It is the mean of that data. So we need to come here and determine our x bar. We know how to calculate the mean of ungrouped data. Just add these values and then divide by the number of observation. In this case, the number of observation is 5 because we have got 5 numbers here. Can you add for me this and then you divide by 5? Yes, 48, 55,
53.6.
53.6.
6.
Okay, that is our x bar. Remember these values that we have, these are our x's. These are our x's. So this is x1, x2, x3, x4. These are actually the x's that we are referring here. So when we say the summation, it is simply going to be like this. So we have our x's, which is 48, 55, 60, 63, and 42. And then we can have a column for x minus x bar. Because already x bar is calculated, it is 53.6. So each x, we minus x bar. So can you do 48 minus 53.6? 48 minus 53.6, what do you get?
Negative 5.6.
What about 55 minus 53.6?
1.4.
1.4. What about 60 minus 53.6?
6.4.
What about 63 minus 53.6?
6.4.
Thank you. What about 63? 63 minus 53.6?
9.4.
Lastly, 42 minus 53.6.
Negative 11.6.
That is 9.6. Remember that is, I hope you are able to connect how we are doing it. X
Negative 11.
11.
Negative 11.6.
Okay, thank you. So here, you need to understand how we have computed or how we have prepared that column. It is the, first of all, you get the mean from that data. That is becomes your x bar. And because we need x minus x bar, the values that were given here, those are your x's, you list them down. Then now each value, you minus the x bar that you have calculated here so that you can have x minus x bar. After doing that, now you get x minus x bar squared, because the formula is requiring us to square. So it is the value for x minus x bar. Now you square. If you square negative 5.6, What do you get?
Negative 31.36.
Something is wrong. If you square, everything is going to be positive, because this negative 5.6 squared is the same as negative 5.6 times negative 5.6. Is it giving you negative or positive?
31.3.
Yes, all of them must be positive. 31.3, 1.4 squared,
1.96.
6.4 squared,
40.96.
what about 9.4 squared,
88.36.
lastly, negative 11.6 squared,
134.56.
Now you add this column. This is the column that we need the sum for. Remember here, the formula is saying we sum x minus x bar squared. So we sum this so that now we can apply our formula. If you add them, x minus x bar squared, what do you get? What do you get? Those who are adding?
294.14.
294.14.
Sorry, 297.14.
297.14. Thank you. So we can come here and we calculate our standard deviation. So it is going to be the square root of 294.14 over n. N is the number of observation here. We had only 5 numbers, so we divide by 5. So what is our standard deviation? Divide that, then you take the square root. Yeah, what do you get? I'm getting 7.6667. So it is either plus or minus 7.67. That is the standard deviation for this distribution. So just note the procedure. The first thing you must do is to get the x bar, which is your mean. Then you get the x minus x bar, which is the x's. Each and every x, you subtract the x bar to get that. And then the value that you get here, you square so that you can get x minus x bar squared. Your interest will be the sum over x minus x bar squared. Then you subject it to the formula, the summation of x minus x bar squared, which is the sum that you got there. Then you divide by the number of observation. You do that calculation, then you take the square root, you get the standard deviation. That is how it is calculated for ungrouped data. And how do you identify the ungrouped data? The data that is not organized into classes. Having said that, we can go to the grouped data. For grouped data, the standard deviation is calculated using the formula the square root of summation of f into x minus x bar squared over the summation of f. That is actually the formula for standard deviation in case you are given the grouped data. So you can be given an example like this, like you are given the classes here and the frequency. So your data is maybe 0 to 50, 50 to 100, 100 to 150, 150 to 200. So you are given the frequency here, maybe it is 4, 8, 3, and maybe 6. Then you are told find the standard deviation for this data. One thing, this is grouped data because the figures are in classes. What you need to do here, first of all, calculate the x bar. Calculate the x bar always, but because this is grouped data and we have captured or we have covered how we get the mean from the grouped data, you need to get the column for x, and then you can have your fx. Then we can be able to calculate that. The x we know is the midpoints of the classes. So the midpoint of this class from 0 to 50, it is going to be 25. We said you add the two, the lower limit and the upper limit, then you divide by 2. This is 100 plus 50 is 150 divided by 2. You find that is going to be 75. This is 100 plus 150, 250 divided by 2 is going to be 125. And then this one is going to be 350 divided by 2. It is going to be 175. That is your x. Then get your fx. You multiply f times x. So the first one is going to be 100. 8 times 75, which is 600. 3 times 125, 375. 6 times 175, which is 1050. You add the fx and you also add the f. If you add that, you find that is coming to 2125. And the f, this is 12, 12, 15, this is 21. Huh? So our x bar will be equal to 2125 divided by 21. Which gives you 101 point, can say it is 101.1.2. That is your mean. Having obtained your mean, then you need to come here. You can have a column for x. Then we have x minus x bar. Then we can have x minus x bar squared. Then because we also need f into this, we can have f into x minus x bar squared. And we shall be done. And we shall be done with that. So what we can do here, our x, we have them, the midpoints, which is 25, 75, 125, and 175. That is our x's. Then now we can do x minus x bar. Remember, we have our x bar here. So we can get it. If you do that, assist me to do this. Somebody to do from the bottom. You just get x minus x bar so that we can finish a bit faster.
The first one is negative 76.2.
Negative 76.2. Who has somebody an answer for any figure here?
Negative 26.2.
125 minus 101.2.
23.8.
23.8.
23.3.
0.8.
0.8. Uh-huh. 175 minus 1.2.
73.8.
Having obtained the x bar, the x minus x bar rather, we can now be able to calculate this. And I think it is better we go across so that we don't keep on feeding these figures in the calculator. Now that we have x minus x bar, can we square that? Can you square negative 76.2 so that we can get x minus x bar squared? We can go across 76. Are you getting 5806?
Yes, 5806.44.
Yeah.
0.44, eh? Because again, we are going to put this figure here because we have times x minus x bar squared. We just multiply by f direct. That figure we multiply by f so that we can fill here. It is x minus x bar squared, which is this figure. Then we multiply by f for that row. So we multiply by 4. You find that is going to be 23. 225.76. So we can come again here, negative 26.2 squared. You get is going to be 686.44. Then you multiply by the frequency for that particular class, which is 8, so that we do it once. 54, 91. 0.52. We come again here, 23.8 squared. 566.44. Then we multiply by f for that particular row, which is 3. It becomes 1699.32. Then we do the last one, 73.8 squared. 73.8 squared. 5446.44. Then you multiply by the frequency for that class, which is 6. That 2.
67.8.64.
Yes. 0.64. From our formula, what we need, it is the sum of f into x minus x bar squared, which is this column here, f into x minus x. Let us add them so that we can get the sum, and we put it in our formula here. The formula requires we get the sum for that, and we have it here. So if we add that, 1699. You get 63.
63095.24.
That is the sum. So we are now able to calculate our standard deviation if we put it here. Therefore, we can say that our standard deviation is going to be the square root of 63,095.24 divided by the summation of f. We normally divide by the summation of f, which we had done here. The summation of f was 21. So we divide by 21. So can we divide this by 21 and then we take the square root? then we do the root of the answer. You find that it is the standard deviation will be positive or negative 54.81. Plus or minus. It is always plus or minus because the deviation can be, or you can find the values above the mean or below the mean. So it is plus or minus that. And that is the standard deviation. So you need to understand the procedure is what is important. Whenever you are calculating the standard deviation, always start by getting the mean, which is your x bar. Now you can have your x minus x bar. Remember the x, first of all, is the midpoints of the classes. So that is your x. So you can have x minus the x bar that you have calculated. All those values of x, you minus the mean. Then you square that. Then you multiply by the frequency for that particular class. And then you sum this. This is what we need. And you will be sorted. Having done that, the next measure of dispersion is actually the variance. But the moment you have understood how to calculate the standard deviation, then the variance, it is a walkover. The variance is simply the standard deviation squared. It is simply the standard deviation squared. So the moment you have obtained the answer for the standard deviation, you square that answer, and that is the variance. But if it is to calculate it, you will find that for the standard deviation, we are actually taking the square root. But for the variance, if I can start with the ungrouped, variance will simply be the summation of x minus x bar squared over n without having the square root. For the grouped data, the variance will be given by the summation of f into x minus x bar squared over the summation of f without taking the square root. Those are the formulas for the variance. That's why I was saying the moment you have understood how to do the standard deviation, then the variance is just a walkover. You don't take the square root, you leave the answer like that. Having said that, we can go to the last measure of dispersion that we can be calculating, which is the coefficient of variation. Which again, we are not going to do because we have done all that. Coefficient of variation, it is simply the standard deviation of the mean times 100 or percent. It is normally in percentage. So you'll find it, maybe it is represented by that. The standard deviation is normally presented by this sign. The mean is normally presented by x bar times that. So if, for example, you were to get the standard deviation for this data, sorry, the coefficient of variation for this data, it is simply the mean that we obtained here, and we also have the standard deviation here. We just divide this one, the 54, divided by the mean, which was 1 point something, then we multiply by 100. That is the coefficient of variation. I don't know if you have any question up to that point. Anybody with a question? You realize that the measures of dispersion, anything that has got a formula, actually, when it comes to